So in 432, we're looking at the Babylonian quadratic formula, which is actually a continuation of the completing the square approach that we did in the last section. I can kind of show you based off of something that we did earlier. Let me paste in that work. It was a few pages ago. Let me see. Page 155, where I was doing a side-by-side comparison between the general terms, like the A, B, and C values, and then the examples that had particular numbers in it. But then once we got to the part where we took the square root, I just wrote solve for x, right? And numerically, that wasn't a problem because we could, we got x plus 1 equals 4, and we just went from there, right? But if we were to continue working with the letters rather than the numbers, we would have gotten to another formula. So I'll take you through that now, just to show you. But ultimately, it'll be a matter of just applying another formula, right? So the solve for x part of it. So I'll get rid of that. On the left-hand side, it's x plus b over 2. On the right-hand side, it's kind of a mess, right? If you look at what we're supposed to end up with in terms of the formula, it's supposed to be kind of a mess, all right? So we're stuck with a radical here. I can write this as c plus b squared over 4, just to kind of clean that up. Now, depending on whether we're using positive or negative numbers, really that's related to whatever kind of problem we're working with. Right? The Babylonians were only concerned with positive values, but we also account for negative. So I'm going to slap a little plus or minus in front of this. All right. And then I'm going to subtract the b over 2 from both sides. And that's going to give me x equals negative b over 2 plus or minus. I'll write this with the b squared over 4 coming first, plus c. All right. What this version of the formula has, instead of a, b's, and c's, it's using, well, actually, we never used the a. We would be using p and q, all right? But it's essentially the same thing, all right? So if I had x squared plus px equals q, then my formula would be negative p over 2 plus or minus the square root of p squared over 4 plus q. Right, and that's the Babylonian formula that you see here. All right. So that's a typed version of the derivation, but I thought it made sense to kind of build off of what we were doing last time. All right. But computationally, it really is just a matter of plugging it in. All right. So I'll take you through this example. All right. So I'll put my formulas here. All right. So I have x squared minus 2x minus 15. So x squared minus 2x minus 15 equals 0. All right. I want to have it in the appropriate form, so I'm going to add 15 to both sides. And I'll get x squared minus 2x equals 15. All right, so p would be equal to negative 2, and q would be equal to 15. So x is going to be negative, well, it's built into the formula, negative 2 over 2, plus or minus negative 2 squared over 4 plus 15. All right. Negative, negative is positive, so this is going to boil down to a 1, plus or minus. Negative 2 squared is 4, divided by 4 is 1, plus 15. So 1 plus or minus the square root of 16. Square root of 16 is 4. That happens to be a perfect square. And so we're looking at 1 minus 4, which is negative 3, or 1 plus 4, which is a 5. All right. Now, with the Babylonians, assuming that it's a Babylonian context, we would only go with the positive number. All right. So we would focus only on the x equals 5 if it's designated as a Babylonian quadratic formula question, QF for quadratic formula. All right. So the next problem's essentially the same thing. All right. So we can plug and chug away. Two. So example 2, I never wrote example 1 here. All right, x squared plus 6x minus 40 equals 0. This looks pretty bad, so I'm going to fix it. All right, so I'm going to add the 40 to both sides to get started. All right, and then I identify my P and my Q. And then solve for x. All right, so negative P over 2. I'll bring the formula so I can point to it. Oh, lordy. Pretend I didn't say any of that. It's right here. All right, so negative 6 over 2 plus or minus the square root of 6 squared over 4, all right, and then plus that Q value, so plus 40. So negative 3 plus or minus 6 squared. You can do it all in one shot if you want. 6 squared divided by 4 plus 40. That's going to get you a 49, and then take the square root of that. So negative 3 plus or minus 7. So x is going to be equal to negative 3, negative 3 minus 7, which is negative 10. Or x will be equal to negative 3 plus 7, which is 4. And again, if it's Babylonian, we would only go with the positive value. All right, solve using the Babylonian quadratic formula. All right, which implies this Babylonian context. I think somewhere up here, why are negative solutions unacceptable for a Babylonian problem? Because they were concerned with geometries. All right, so this was used specifically for, and we addressed this in the Babylonian completing the square. The genesis of this came from the need to solve real world problems. I'm trying to see if there's I don't remember exactly where it is, but we're talking about geometric figures, rectangular figures, bounded areas, right? So if you're talking about like a parcel of land, you wouldn't necessarily consider its dimensions to have a negative value, right? But that's the idea. All right, so that's your Babylonian quadratic